Okay, so motor main part, motor torque already finished, motor losses, you know that motor loss and generator loss same. These are three types of losses. One name is the copper loss, another core loss or iron loss, and third is the mechanical loss or friction loss. Okay, then the complete power stage diagram already complete. Power stage diagram, okay, power stage diagram already complete. Motor speed already complete. Okay, so characteristics of motor, this your assignment. Okay, so this part is also complete. So our 29 chapter is finished, and 30 chapter almost finished. Chapter 30 is the speed controlling of DC motor. We know that speed controlling of three types: is the voltage control method, then the field control method, and armature resistance control method. And these apply our two types of motor, the shunt motor and series motor. Okay, are we clear?
Yes, sir. Clear.
So today our very important part is this part name is the starter. You know that starter?
No, sir.
You know that starter? I mean,
No, no, sir. No. I don't know.
starter. Starter means the starting element. Okay, starting device. Starter is the starting device.
Sir,
Why
tube light
striker.
use করা হয় যে ওইটা
Striker. Striker.
Starter. Start R. Okay, starter. This is the starting device. Why you use starter? So starter, the very important device in our motor part. Why is the important starter? Why? Anybody? It's not. বলতে পারবা স্টার্টার কেন ব্যবহার করা হয়? স্টার্টার কেন ব্যবহার করা হয়? Why you use starter? Amir,
Yes, sir. I can hear you.
why you use starter?
For what? Striker or starter?
Starter.
Starter. I don't understand, sir.
Anybody? This name is the starter. Okay, starter.
Stretcher. Okay. Stretcher. Stretcher. Motor starter. Yeah.
Motor starter.
Okay, motor starter.
Why you
Yes.
need starter?
Okay, this is like a switch.
Yes,
Yes.
Start.
It
Now we
has.
discuss starter. Okay.
Okay.
So that our suppose this starter is very important. Okay. You know that this your motor. Okay.
It's your DC motor.
This your motor. Suppose series motor or shunt motor, no problem. Okay, just this the motor. Okay, and this is the supply. Suppose 220 volt. Okay,
Yes, sir.
but this whole 220 volt no need your motor
Okay.
because you know that at first this voltage is passing this resistance, then motor is rotate, and this section is must be power developed. This called back EMF, EB. So this is the very important back EMF. Okay, so this voltage minus, suppose your this section is development voltage is 190. Okay, development voltage 190. So this your supply voltage and this your development voltage. Then 190. So this 30 volt, this voltage needed your motor. Okay, no need 220 voltage, full no need your motor. Only
30
motor,
volts.
motor needed voltage just 30 volt. Yes. Because this is the back EMF, this is the minus voltage, okay, the back voltage. Okay. But at our motor starting moment, if you just direct this 220 voltage supply, if this supply is through this motor, then this motor is only needed 30 volt. Okay, but you throw 220 volt, so must be this motor is burned.
Yes, sir.
Because this load, maximum load 30 volt, but your supply voltage 220 volt.
Yes.
Okay, so this not possible directly hit in our motor part.
Yes, sir.
So we need at first slow motion. This voltage at first needed only 30 volt because our motor running needed the 30 volt. So we need 30 volt. So at first you throw 30 volt, then this motor is run. This motor run, then back EMF develop, then suppose back EMF develop 10, then you need 40 volt. Okay, back EMF 20, then your voltage is 50. Okay.
Okay.
Then this the variable voltage increase. This part increase if development voltage is increase. Okay. Development voltage increase, then this voltage is increase. Okay. So this section we need the variable resistor. Okay, variable resistor, need the variable resistor. This full 220 voltage through this resistor, then this resistor pass at first 30 volt, then 40 volt, 50 volt. Okay,
it will drop something.
This is the variable part, variable resistor. Okay, this variable resistor called starter. Okay, if this section is complete to fully power developed, complete back EMF, full back EMF complete 190 voltage, then your starter is no need your starter. Then your starter resistance is 0. Okay. This starter resistance at first starter resistance very high. Okay, very high suppose this is your resistance, this ohm. Okay. So then this resistance is high, then this resistance is decreased, then voltage increase, this resistance decrease. Last moment this this resistance is 0, then full voltage 220 voltage is passing this section. Then 30 volt needed our motor and 190 voltage needed the development power. Okay, so this
back
the
limit voltage.
okay, so back EMF voltage. Clear?
Yes,
So
sir.
motor section, in this case, motor section must be needed the starter. Okay,
Sir, if you
but suppose you are not apply starter, then must be this voltage is the regulated voltage. At first very low voltage, 10 voltage, 20 voltage, then and slowly your voltage increase. This section is increase your voltage, suppose 20, then 30, 40, increase, voltage increase. If this increase, then your slowly your back EMF develop, then your back EMF, if your back EMF 190, then this section is full voltage is passing this section. Okay, so this section is needed the one variable resistor. This variable resistor is automatically controlled variable resistor. This automatically controlled variable resistor, this variable control resistor name is starter. Okay, starter. Okay, all are clear?
yes, sir. Clear.
Now I will just explain Somalian language in your frame.
Okay, sir. أصحابتا
Yes, starter.
ها waa fahansantii maano macalinka wuxuu ka hadlayaa strator marka waa variable resistor waaye hadda laakiin macalinka hadda sawir uu tusinaya wax switch u eg uu ahaa hadda ma aqaan wuxuu isku bedelay variable resistor uu noqday daay marka suppose hadda meeshan hadda u jeedaan oo mataqaana output-ka waxaa laga soo supply grade 220 volt 220 voltage marka haddii 220 strator macnaha waxyaabaha uu qabanaya faa'iido uu leeyahay oo macalinka uu sheegay marka haddii 220 volt ku apply gareeyo diagramkayga ama circuitkayga hadda ku apply gareeyo motorkayga waxaa dhacayso in mataqaanaa horta motorka markuu voltage uu soo maro wuxuu soo saaraa waxa la dhahay back limit voltage ama EB. Okay, had EB-gaas marka wuxuu u baahan karaa 190 lagu dhahay maximum 190 voltage uu u baahan yahay. Okay, marka motorkaygana DC motorkaygana wuxuu u baahan yahay 30 volt. Okay, isma qaadanaysa marka waxaa dhacaysa haddii 220 sideeda ay u marto mataqaanaa motorkayga waxaa dhacaysa in motorkayga uu gubto marka si aan sidaasi mataqaanaa kaga hortago waxaa sameynaa u dhahay waxaan ku apply gareynaa strator waxaana mataqaanaa uu kasii dhanka ay kasoo galayso voltageka strator marka waxyaabaha faa'iido uu leeyahay mataqaanaa motorka saasaa ka mid ah ma fahamtay inuu step down uu ku sameeyo matalan voltageka uu kale iyo si mataqaanaa maximum voltageka oo motorka u baahan yahay uu u gaaro oo lagu talagalay
صح
intuu macalinka dhahay intuu sheegay fahanteen
ها ماشي
baan sharaxaad baan idinka raadi karnaa saar
Yes.
complete
So just one second. just 1 minute. You just listen.
We will link that video in the description below. Today, however, instead of talking about all of the components that make up the motor starter, we want to talk about why it is important that we use motor starters. Electrical motors are extremely common and are used in a wide variety of applications, from fans to drive systems, pumps, just to name a few. In some cases, it is possible to provide power to the motor directly from the utility power source. However, there are many cases in which providing power in that manner can potentially damage the motor as well as other vital components on the utility line. Not to mention, it can possibly overload the line as well. It's because of some of these variables that we use motor starters. Typically, you will not see motor starters being used on smaller motors. Anything above 5 horsepower is where we start to see them being implemented. So why is it so important that we use motor starters on larger motors? First and foremost, the purpose of the motor starter is to provide protection for both the motor itself and the operator who is controlling it. This protection comes in several different forms. First, let's talk about protecting the operator. In order to be able to turn a motor on and off, there needs to be some kind of switching device. If the power going to the motor is being switched manually by an operator, it can create all kinds of hazards, such as arcing, which can be very dangerous depending on the amount of voltage that is being switched. By using a motor starter, it offers us the ability to encapsulate the switching mechanism within the starter housing, which is a much safer method of turning the motor on and off. Also, depending on the starter that we are using, it may also give us the ability to start the motor from a remote location, which can further increase the safety by removing the operator from the area where the switching will occur. In regards to providing protection to the motor itself, the starter is critical. When a motor is started, there is typically a large inrush of current. This inrush can put a lot of torque on the motor and other motor-related hardware. Also, the inrush of current can prematurely wear out and cause early failure of the motor because of the stress created on the hardware within the motor itself. In DC motors, the armature in the motor has a very little resistance, and the high current levels that can occur from starting a motor without the use of a starter can damage the armature on the motor's very first use. So in the case of both AC and DC motors, especially higher voltage, more horsepower situations, the motor starter is critical. The right kind of motor starter can reduce the high levels of inrush current, prolonging the life of the motor. These are the types of situations that you will commonly see a soft start feature on the motor starter being used. These types of starters will limit the amount of voltage that is applied to the motor initially and will gradually increase voltage until the motor is running at full speed. This control will again help prolong the life of the motor over time. These are just a few simple examples of why using a motor starter is critical to the longevity and overall functionality of the motor, especially in larger motors. There are several other reasons why motor starters are an important part of the overall motor control system, which we will not cover today. Hopefully, by watching this video, you will have a better understanding of why we use motor starters and why they are so important. For a full line of motor control equipment and thousands of other products, please go to our website. For more information or other educational videos, go to rfpsupply.com, the internet's top source for industrial hardware. Also, don't forget, like and subscribe.
Okay, all are clear? Amir?
Yes, sir.
So motor starter is very important. Okay.
Yes, sir. Even we saw the functions of motor starter.
So this just motor starter. If you not use the starter, just no problem. But then just use your voltage this motor. If you not use starter, okay, if you not use starter, then must be your voltage not throw directly full voltage, 220 voltage support, not direct through 220 voltage. This voltage must be slowly increase. Okay, if you slowly increase this voltage, then and your motor is safe. If you direct this voltage through, then maximum current flow this section, and this motor is must be burned. Okay, so we need the, if you this voltage is direct through, then must be used the starter. Starter is this the section, this is the slowly current flow. Okay, if increase if develop the backward voltage, then and this last section, this the starter is 0. Okay, 1 minute. Okay, so this starter are two types. Okay, one is the 3-point starter and another name is the 4-point starter. Just this. This necessity of the starter. Okay. This is the starter. Okay. This is your starter, 3-point starter. And this is your 4-point starter. This is the 4-point starter. Okay. So this is the starter. Okay. Amir,
Yes, sir.
this is your topics, starter topics. Okay.
Okay, sir.
This is your another assignment. Okay. This assignment just discuss about the starter and necessity of a starter. Okay. Study starter, all part. Okay. Why use the starter? Necessity of the starter. Okay.
Sir, we have to write all these things, or we have to do arrangement like some questions.
Yes. Just describe the starter.
Okay.
Okay. The starter just at first point. Okay.
Okay, which page? It's 1076.
Sorry.
This page number.
Page number.
1000. Page number.
Page number.
1076.
76. This is your
1076.
75. Also 75. Okay.
Yes. All this
Motor
about the starter.
Okay. All.
Okay.
Yes,
Okay, sir.
Okay. 30.19.
Okay, sir. Inshallah.
Okay. So it also must be described 3-point starter with this diagram and 4-point starter with this diagram. 4-point starter.
We have to draw.
Yes, must be drawn.
Okay, sir.
4-point starter, 3-point starter.
Okay, sir. Inshallah.
Okay, so almost our DC motor part finished. Okay. At first complete our transformer, then we repeat our generator, some topics, and motor some topics. Okay.
Okay, sir.
So must be our at first we need the syllabus. All part is just task all section. Okay. So today our another topics. This topic's name is transformer. Okay. Transformer chapter. This chapter named 30 number chapter. So, sorry, 32 number chapter. Okay. This is the 32 chapter. This is the transformer. Okay. So transformer. This transformer is big syllabus. Okay. 6 pages. So you know that transformer. Transformer means transfer. Okay.
Yes.
This device just transfer our power, one circuit to another circuit.
Yes.
Okay, but
It step down the voltage.
step down, step up. This the another part, transformer part. But
Yeah. Oh,
transformer main part. This part is the only transfer. This is the just to go up transformer. So this is your transformer. This is main part. This is the part. Okay. This one circuit. This
Coil.
coil. Okay.
Yes, sir.
Another coil. This another coil. Okay. So this name is primary coil and this name is secondary coil. Okay. But this coil and this coil, no connection, direct connection, this coil and this coil. Virtually connect. Virtually connect means this coil at first, if you throw the power, this coil, then must be develop the flux. Okay. Must be develop the flux, this magnetic flux, this flux transferred to this section and this coil is active. Then this power is transferred this section. Okay, so this transformer main things is power and frequency. Same power and frequency transfer this circuit to another circuit. Okay,
It
one
is
circuit to power and frequency transfer
Understand.
another first circuit to another circuit. Okay, this circuit and this
Transfers.
circuit different.
Again, sir. Again.
This is the transformer. This a transformer is a static machine. One kind of static machine. Apparatus, machine or apparatus by means which electric power is the electric power in one circuit to transform electric power. This circuit power transferred to another
circuit.
Okay.
Oh,
So
okay.
electric power in one circuit to transform into electric power of the same frequency. So frequency and power both are same. Transfer this section to this section. Okay.
Okay, sir.
Yeah. This is the main part. Electric power in one circuit to transform into electric power of the same frequency in another circuit. Okay.
Okay, sir. Okay.
So this the things. This circuit to this circuit, same power and frequency transfer. Suppose this section, this is the primary section and this is the secondary section. This primary section suppose power 1000 watt, so must be this section power 1000 watt. And suppose this frequency 50 hertz. Okay, this frequency 50 hertz means per second 50 pulses. Okay, per second 50 pulses. So must be secondary part per second 50 pulses. Okay, so frequency and power both same. This section, primary section and secondary section. So why you use the transformer? Same power, same frequency. So why use this section to another section? Okay, this the important part. Our power same. Suppose we need the voltage down. This section, suppose this section, our voltage to 250 volt and current 4 ampere. Okay, primary section. Clear? So power, you know that P is equal to VI. So 250 into 4. So 1000 watts. This is the primary part. Okay, all are clear?
Okay, sir. Yes, sir, clear.
So now we need the voltage down. Suppose we need voltage, we need our charger circuit. Okay, so we need the voltage only 5 volt. Our mobile charger. So must be needed our transfer voltage. Secondary part needed 5 volt. Okay, so this 5 volt secondary part voltage 5. But power, you know that our transformer power same. So voltage 5. So current must be increased because our power is equal to 1000. P is equal to VI. So I is equal to P by
V
V.
divided by V, yes.
So 1000 by 5. So 200 ampere. This current is 200 ampere. Secondary part, our current is 200 ampere. Voltage decrease, but current increase because our power same.
Okay.
Clear?
Yes, sir, clear.
Bengali students? Any Bengali students? Misbah?
Yes,
Misbah,
sir.
বুঝতে পারছো বিষয়টা?
Yes, sir.
So transformer, our transformer must be AC, not DC. Transformer must be AC because frequency available. Frequency available. You know that our DC frequency is equal to 0.
Constant, yes.
Frequency
Will
no
be
need the
0.
frequency or DC circuit. DC circuit frequency, DC circuit, this is the straight line.
Yes, sir.
Okay, our voltage straight line. All time 5 volt. Suppose 5 volts, so all time 5 volt. 10 volts, so all time 10 volt. But AC 10 volt means increase at first a high voltage 10, then 0 to 10, then 10 to 0, then minus 10, then 0,
to
then
0,
this
yes.
the increase or decrease any 50 second. Per
It will be
second,
changed.
per second, 50 hertz, 50 times changes. Per second, 50 times changes in this AC. Okay, but DC all time same. So transformer not DC. Transformer all time AC. Okay, but so why you use our mobile circuit? Transformer. Suppose this your mobile circuit, mobile charger. Okay, so mobile charger must be needed one transformer. Okay, this is the transformer. This transformer, you know that our mobile charger to connection is the AC connect 220 voltage. This is the supply. Okay, plug, charger plug. But this charger at first this voltage through this transformer, then this transformer transfer step down. This is the 5 volt. But must be 5 volt AC because transformer not convert AC to DC. Transformer just convert, just only transfer power and frequency same. So previous frequency 50 hertz, so must be these are 50 hertz. So, but we no need the AC 5 volt. Our charger needed DC 5 volt. Okay, clear? Our mobile is DC. So our this AC to convert this AC 5 volt to convert DC must be needed our rectifier circuit. You know that bridge rectifier? Bridge rectifier?
Yes, sir. Diode.
Okay. Diode, 4 diode.
with
then
bridge.
bridge rectifier. Okay. Okay. So this transformer then connect this bridge rectifier. Okay.
At that time, you convert it to DC, AC to DC.
This 5-volt AC to convert this 5-volt DC. But this not pure DC, this is the pulsating DC. Then if you use filter circuit, you know that filter circuit already we discussed your electronics 2 subject, okay, or electronics 1 subject maybe. Electronics 1 is the rectifier, half-wave rectifier,
Half-wave rectifier, full-wave rectifier.
yes.
We learn
then
about
the RC
electronics 1.
filter, okay, RC filter, okay. Then if you use filter circuit, capacitor and resistor, use this circuit, then this circuit is pure DC 5-volt. This 5-volt connect to our charger point, mobile charger point. So this the charger circuit. This is your supply 220 AC volt, but your charger is DC 5-volt. Okay, this is the AC 220 volt. So this AC to DC converting device, one device is the transformer. This transformer this not convert AC to DC. This only step down. Step down. If you need 10 volt, then convert 10 volt. If you need 5 volt, then convert 5 volt. This 5 volt is AC. Then this AC to convert DC must be used the rectifier circuit and filter circuit. Then the pure DC. This pure DC is connect our mobile charger. Okay, all are clear. So transformer is very, very important device. And another, our substation onto distribution line transmit, then must be needed a transformer, then this transformer to this transformer. Suppose you know that our development section and voltage is very high, 33 kV, kilovolt, 33,000 voltage. But our home service voltage 220. Okay, so this voltage to convert 220 voltage must be needed step down transformer. Okay.
Okay, fine.
Yeah. So these are very important topics. Transformer. Okay. So now this is the transformer. This is what it is called a transformer. Transformer construction. This is the coil, primary coil. This is the secondary coil. Okay. Then transformer, many types of transformer. This transformer just design change, then name change. Okay. This is a port type transformer. This is the port type transformer, and another is the cell type transformer. Cell. Okay. This is the cell type transformer. This is the one cell. Okay. This is the cell type transformer. This is the cell path. Okay. Mini path. 1, 2, 3. These are maybe 20, 25 path. Different path. Okay. So there is a transformer. Ideal transformer must be our voltage and primary and secondary power almost same, but practically transformer just some losses. Okay. The step up transformer, step down transformer. So now it is a very important gamification of that. Okay. So now our topics this one. Gamification of transformer. You know that this is your primary coil and this is your secondary coil. Okay, this is the ear gap. Okay, so this turn name is primary part turn name is N1 and secondary part turn coil turn name N2. Okay, number of turn N1 is equal to number of turn in primary, N2 number of turn in secondary. Okay, and this one timing cycle. Well, this is the flux. Okay, this flux, this point is maximum flux. Okay, flux increase. You know that flux, maximum flux, phi is equal to A bar. Okay, phi is equal to A bar, and this phi means this point is maximum flux. Okay, high. You know that our voltage increase and decrease. 1 second, and these are 50 times increase and decrease. Okay, well, clear? So this point is flux. A means maximum flux. Okay, so and this is the frequency. This is the full one time cycle. This point to this point, this is the one time period. Okay, this is the one time period. This T is equal to, you know that T is equal to 1 by 5. All are clear? T
Yes,
time period is equal to 1 by frequency, or frequency is equal to 1 by time period. 1 by time period. Okay, F is equal to 1 by T, or T is equal to 1 by F. This is the frequency law, frequency and time. So this the full time. So this must be half time, and this must be quarter time. Okay, this is the quarter, and this is the half, this is the 3/4, and this is the full. Okay, all are clear?
yes, sir.
So this is the quarter movement. Your flux is maximum. This is the maximum point. Okay, when this flux is maximum, your time period is quarter. Okay, so T4 by 4/8. Okay, in this section, this is the quarter section, this is the half section, and this is the 3/4 section, this is the full section. Full section T is equal to 1 by 8. So this is the 4 by 8, this section. Okay, and you know that flux is equal to flux density into area pore. Okay, A means coil area. Okay, our coil is 10, 3 meter. Our coil is. Suppose this coil is your stem. Coil is 10. Okay, this is the area. This area is A. Okay, and this coil, if this coil is silver, then flux density different. If these are gold, then flux density different. So flux density depend on your coil. Okay, so this the coil, this coil, flux means flux density into area. Okay, flux density into area. Flux density different coil and flux density different. This is the fixed. Okay, silver, gold, all are different flux density. So all are clear this part. Phi m maximum flux in core, in Weber, and this is the maximum phi flux is equal to flux density into maximum flux density into area. Okay, and F is the frequency. Okay, so you know that our flux is equal to phi is equal to sorry, EMF is equal to our voltage. Our voltage is equal to charge by time. Okay, voltage is equal to, anybody? Hasnat, বাঙালিটা কি রেসপন্স করে না? হাসনাত আছে? হাসনাত তুমি বুঝবা?
নেট প্রবলেমে শুনতে পাচ্ছেন নাকি স্যার? সমস্যা
তুমি তো আছে নাকি?
ইয়েস স্যার, আমি স্যার
বাঙালি আর কি আছে? সাজ্জাদ?
Yes, sir.
বাঙালি
Yes, sir.
সাজ্জাদ আর কি আছে? বুঝবা দুইজন আছে।
আরো দুইজন ছিল স্যার, সাইফুল ছিল, সে মেবি বের হয়ে গেছে, সাজ্জাদ ছিল, সে বের হয়ে গেছে।
Yes, sir.
সাজ্জাদ আছে, সাইফুল আর হচ্ছে হাসনাত।
স্যার আমাকে ডাকছেন স্যার।
বুঝতে পারছো কিছু?
জি স্যার, বুঝতেছি স্যার।
না বুঝলে তো বলবা যে স্যার বুঝছি না। So flux, the voltage is equal to charge by time. Charge is the charge means is the flux by t. So you know that flux, this is the max flux means this is the maximum flux. Okay, average rate of change of flux, average voltage means average change of flux. This is the maximum flux, and in this time, this is the average time 1/4f. Okay, t is equal to 1/f, and these are 1/4f. Yes. Okay, all are clear? So this is the volt is equal to this is the maximum flux, and t is equal to 1/4f. Okay, so this. So just this is the multiplying this section to this, it is the 4 IMF or 4f IMF. This is equal to this. Okay. So Weber, this is the flux means Weber, and time is second. So Weber per second is the unit. Weber per second means volt. Okay. Weber per second means volt. This is the Weber per second. This Weber per second means volt. And average EMF per turn. So this is the average EMF per turn. Okay, average EMF per turn. So you know that our form factor is the AC. So we need the form factor. Form factor is fixed. Form factor means RMS value by average value. Form factor means RMS value by average value is equal to 1.11. This is the fixed. Form factor is the fixed 1.11. So our RMS value is equal to this 1.11 into average value. RMS RMS value is equal to 1.11 into average value. Average value. So 1.11 into average value is this 4.4 F5. So now 4.445. Okay. All are clear? This is the RMS value. You know that our AC part must be needed the RMS value. So RMS voltage. Okay, RMS value this 4.44 into 5 F into 5. So this is the one turn. So if you turn increase, then voltage, this voltage is per turn voltage. So if turn increase, so this is the turn N1, so this is the primary voltage. If you multiplying the N2, then this is the secondary voltage. Okay, so Q1 is equal to this is the 4.44 5 mF N1, or E2 is equal to same 4.44 5, just this is the N2 5, and you know that 5 means maximum flux density into F. Okay, all are clear?
Yes, sir.
Yes, so this is the EMF equation of transformer. So if this this is the fixed, this frequency fixed or flux fixed, so our voltage depend on the turn ratio. Okay, if this part is fixed, this fixed, so E1 proportional to N1 or E2 proportional to N2. So voltage depend on the coil turn, depend on your coil turn. If coil turn increase, your voltage increase. Suppose we need the step down transformer, so must be needed the, if this secondary part is turn decrease, so secondary part voltage decrease. This is the turn depend on your voltage. Turn decrease, voltage decrease. Turn increase, voltage increase. Suppose this turn increase, so this section is voltage increase. This section we need the voltage decrease, so must be decrease the turn. If you decrease the turn, then this section is voltage decrease. Okay, so all are clear?
Yes, sir. Because they are directly proportional to each other.
Okay,
Yes.
because if this section all are constant. Okay. So these that depend on these voltage increase or decrease depend on your turn ratio. Okay. So, this. Okay. So this is the turn ratio. Okay, this if the constant value k, so E2 by E1 is equal to N2 by N1 is equal to k or A. Okay. So if the voltage step up, so must be the N2 is increase. If step down, so N2 is decrease. Okay. If we need step down transformer, so must be decrease the N2. And if the step up, so must be increase the N2 into coil increase, then voltage increase. Okay. So first we are applying one question. Okay, so this is the question. Okay, no problem. This question. Let's solve this problem. Okay, this problem. This is the transformer, 25 kVA. kVA means this is the power. Okay, kilovolt ampere. Kilovolt ampere, you know that P is equal to VI. V unit volt and I unit ampere. So VA means power. Okay, power unit VA. kVA means kilovolt ampere. So 25,000 volt ampere. So this is the power. Okay, transformer power has 500 turns. So power this is the power. P is equal to 25 into 10 to the power 3. And turn N. Turn on the primary. So N1. N1 is equal to 500 turn. Okay. And 50 turns on the secondary. So N2 is equal to 50. Okay. The primary is connected to 3000 voltage and 50 hertz. So primary coil, this coil is 3000 volt. So V1 or E1 is equal to 3000. V1 or E1 is equal to 3000. And F is equal to frequency is equal to 50. Okay. Find the full load primary and secondary current. The secondary EMF and first point, find the full load primary and secondary current. So primary current and secondary current, first point I P and IS is equal to primary current and secondary current. And second part, the secondary EMF. So E2 is equal to what? Okay, secondary EMF. And the maximum flux in the core. So phi m is equal to, neglect the leakage drop and no load primary current. Okay, this is the neglect. Okay, so already you know that our transformation ratio E2 by U1 is equal to N2 by N1 is equal to K. Okay, so this is the another part. N2 by N1 is equal to K. So transformation ratio, this is the N2 by N1, 500 by 50. So transformation ratio is equal to 10. Okay. If primary part 5 volt, so if secondary part, this is the 1:10 transformation ratio. This is the 1:10. If 10:1. This is the 1, then this is the 10, and this is the 1. 10:1. Okay. So primary voltage, if primary voltage 5, secondary voltage 5, so primary voltage must be into 10. This is that ratio. Okay. So 50. This is the calculation. This, so N2 by N1 is equal to K. Sorry, yes, 1:10. these are, sorry, M2 by M1. So 50 by 500. So 1:10 ratio. Okay. Secondary by primary, 1:10. Okay, 1 by 10. And current, also current, you know that I is equal to P by V. So P is equal to 25,000 and V is equal to primary voltage is equal to
50.
3,000. Okay. So these are primary voltage, a primary current. IP is equal to, or I1 is equal to 8.33. Okay.
Your primary current.
Yes, this is the primary current because this is the power is primary and secondary power same. Power is this, and this is the primary voltage. So primary current is equal to the power by voltage. Okay. So this is the primary current. Yeah. So primary current is. And you know that this is the transmission ratio 10. So if this is the primary current this, so secondary current must be increase because this is the step down, current increase, voltage decrease. Okay, this is the turn 50 turn. So turn, if turn increase, voltage increase. So if voltage increase, so current decrease, and voltage decrease, so current increase. So primary part, if primary current this, so secondary current must be into 10. Okay, so IS is equal to 8.33 into 10 because 10 your transmission ratio. Okay, so 83.3. This is your secondary. Okay. And secondary EMF, you know that this is the turn ratio. If primary voltage is then 3,000, so secondary must be decreased. So this 3,000 divided by 10, 3,000 divided by 10, so 300 is your secondary voltage. All are clear?
Yes.
Because this your turn ratio, difference ratio 10. If primary 3,000, so secondary must be decreased. Decrease value is 10, so divided by 10. Okay. This apply this. E2 by E1 is equal to K. Okay, all that clear? So now your flux. Last question, maximum flux. So you know that if equation 1 or equation 2 apply, no problem. If you use U1, so 4.44 pi N1 F2, pi. If you use E2, so just change M2, 4.44 pi flux, okay, the frequency F, N2 pi. So pi is equal to E2 divided by this, okay, or E1 divided by this. Clear? Any one apply your maximum flux. All clear?
Yes, sir.
So just today you are complete only one problem. Okay. Suppose this. In 32.6. Solve this question. Why not solve this question? Please solve this question. Amir, quick start.
codkana ma maqlin markii uu soo waco codka mudug galaa mugta maanta mobilka soo galay oo laptop soo gal jira
هذا الموضوع example كأنك أنا
أنا ka shaqeynaa umaleynaa xiisdiisa mala socdo
waxba loo xiiso wadaanio iska wada cashirka وراه
وريبلا
بو
يور
انت رسالة السعودية تتبع في عايش السنة او نمبر خوش
Any problem, Amir? Hello?
Yes, sir.
We solve this problem. Any problem? This is the question, flux density, peak flux density, okay? Flux density means beta M, okay? And voltage induced in secondary, okay? So E2, this.